what's the best way to prove you're right? If you ask a scientist, it's through inductive reasoning. You ask a mathematician, it's through deductive reasoning. You ask a philosopher, oh boy, it could be through inductive reasoning, deductive reasoning, reductive reasoning, eductive reasoning, transductive reasoning, abductive reasoning, seductive reasoning. Yeah. Now, of all these methods, we trust the scientists. We trust inductive reasoning the most. It's why we talk of scientific proof, claim that the numbers don't lie, and cite studies almost as gospel. In fact, people sometimes put science above gospel, above religion, in terms of finding truth and understanding reality. In fact, the 14th Dalai Lama even said that if science were to prove some belief of Buddhism wrong, then Buddhism would have to change. Now, why is science this trusted when it comes to truth? It's because of the scientific method, which keeps it honest. I'm quite familiar with the scientific method because I was raised by two scientist parents who raised me in the world of scientific rigor. In fact, they're the reason that I put graphs and figures in my thank you notes. Okay, so let's get into the scientific method and why it's such an important thing for us to trust. Well, it all starts with David Hume's problem of induction. All right, over there? Yeah. Okay, so the way David Hume's problem of induction works is science is based on inductive reasoning. And inductive reasoning is where you have something that's true in the past, and you say, okay, it's been true in the past for this many times, it'll be true in the future too. So say we have a sack, and we pull out 5 black marbles, and then we pull out 10, and we just keep pulling out black marbles. And so we say that we will always pull out black marbles. Great, but the problem of induction says, well, what if there's a red marble in the bottom of the sack, and we don't know about it? We'd be wrong, and we have no idea. That's a problem. And so thank goodness we had Karl Popper come in to save us and give us the modern scientific method. So what he said is, okay, we don't know for sure if there is going to be red marble in our sack, but we do know that if we do our best to try to find this red marble before we can be proven wrong, then we'll have something trustworthy here. And so think about it as taking your red sack, your sack with the black marbles in it, tearing it open, and searching with a fine-tooth comb, looking for anything that isn't a black marble. And that's the scientific method we know and love. It's the one we trust, and it's the one that I spent my whole life valuing when I wrote all these graphs and figures in my thank you notes. But what also happened is I took some philosophy classes, and then I declared a major in philosophy. And then I started to reconsider all this stuff, and I realized there's some power in deviating from the scientific method too. I mean, we just saw Karl Popper, who came up with the modern scientific method. He was a philosopher. And so deviating from the scientific method, as it turns out, is how we've gotten some of the greatest innovations in history. Now, to keep in mind, let's talk about a few rules of scientific method. First is that if you falsify a theory, it should be discarded and replaced with a new, superior theory that better describes the truth. Okay, so if you find a red marble in your sack, you can't say, we will always pull out black marbles. Second thing that good science does is it avoids assumptions. Science is based on facts, and all assumptions give you is more assumptions. Lastly, science doesn't give us the truth. It only gives us an approximation of the truth. So we can't know for sure that we will always pull out black marbles. There could always be this red marble. It's just through the rigor of scientific experimentation, we become more sure in our approximation. All right. Now, the craziest thing about the scientific method is that it's one of the few topics that really aren't discussed anymore in philosophy. And it's because we have such a consensus on it. That's rare. That's not normal in philosophy. I mean, philosophers are still talking about plenty of things that most people would consider straightforward. How to live the best life, whether or not there's a teapot between here and Mars, and whether or not Julius Caesar is a number. Seriously. Yeah, I find that one a little ridiculous too. Okay. But deviating from the scientific method, this thing that no one talks about, is actually something we should give more credence to. It's a way we can reopen our conversation into the scientific method. Okay, so let's consider the first deviation, the moon landing. And this talk on the unscientific method is not going to tell you that the moon landing was fake. Okay, so the rocket that went to the moon was not just propelled by liquid oxygen. It was actually propelled by falsified physics. I'll go back to that slide. Whoops. Are we there? Yes. Okay. So the falsified physics in question is this equation, Newton's law of universal gravitation, which basically tells us how objects behave under the influence of gravity. And so what this equation can explain is how Mercury can orbit around the sun with an elliptical orbit. What it can't tell us is how this elliptical orbit itself also rotates around the sun. And so the theory following the proper scientific method was discarded and replaced with Einstein's theory of general relativity, which does explain this. And if you ever want to bring this up in conversation, this is called the precession of the perihelion of Mercury's orbit. So there you go. Okay. But when NASA was sending astronauts to the moon, if it were to follow the proper objective scientific method, then it too would have falsified and discarded this theory. But that's not what it did. When it was calculating the orbit of the astronauts, it actually used this falsified theory. So the astronauts got to the moon on a falsified theory, and it worked. It seems that this deviation from the scientific method was all right. I mean, we have a flag on the moon that tells us so. Okay, but that's physics. Physics is messy, it's inconsistent. That's why we have engineers to straighten everything out. Surely math, right? Surely math follows the rules. No. Okay, in math, the greatest open question is the Riemann hypothesis, which has to do with the Riemann zeta function, this equation. And it tells us about the distribution of prime numbers on the number line. And so the question, the Riemann hypothesis, the way it works is we know about how the Riemann zeta function behaves, where its solutions are on this grid, everywhere except for on this critical strip right here. We know, for instance, that there's infinite trivial zeros over here. We also know that on this line, x equals 1/2, we have about 10 trillion non-trivial solutions. The Riemann hypothesis says that all remaining non-trivial solutions are likewise on that line. However, if the Riemann hypothesis were false, all we need to find is one more solution not on the line, and then it would be proved false. Okay, but then remember how we said that science should avoid assumptions? Well, mathematicians have assumed the Riemann hypothesis is true to prove over 300 theorems in math. That's how we know that any odd number over the 5 can be written as a sum of 3 prime numbers. There's a whole body of mathematical knowledge based on an assumption. It's unscientific, but hey, it works so far anyway. I mean, we get 10 trillion tries, and then maybe it'll change. Okay. Now, this is all great, but we have to remember that there's a difference between the unscientific practices that gave us the moon landing and these theorems based on the Riemann hypothesis, and the pseudoscientific practices of, say, the flat earthers. I mean, in this case, we literally have calculated risks being taken here. We knew that Newton's law would be a good approximation to get astronauts 240,000 miles, maybe not a few light years, but it worked for the moon. And we know with the Riemann hypothesis, we have 10 trillion reasons to believe it. And so it seems that deviating from the unscientific method here is not inherently bad. But the greatest deviation from the scientific method is yet to come. All right. So the great theory, the endpoint in physics is called the theory of everything. We want to find the ultimate truth from it. We want to be able to explain the universe with absolute certainty. But if you remember, science doesn't, oh yes, it's abbreviated TOE. Science doesn't give us truths, it gives us approximations of the truth. And so if we're really going to find a theory of everything in all its authenticity, we're not going to find it as an approximation. We need to find the truth. We need to step outside the scientific method. We need to go beyond physics. Now, there just happens to be a philosophical school of thought called metaphysics, which literally means beyond physics. And that's exactly what we need to do this. Karl Popper, for instance, was actually a huge proponent of using metaphysics to find truth. And he even said a metaphysical research program makes it possible not just to judge the possible, judge the success of a theory as an approximation, but as an explanation, but as the truth itself. Okay, so with all this theory of everything metaphysics business, I'll give you the perspective of a physicist and a philosopher, and I hope you'll see from these two the value in doing things unscientifically. So first, consider the physicist, Erwin Schrödinger. He created that equation, the quantum Schrödinger equation. It's a monstrosity, but you really have to understand the universe and all its intricacies to be able to come up with something like that. Now, at the culmination of his career, he wrote a book called My View of the World. And I mean, it's his view of the world. He could have chosen to work on the universe and explain it from the bottom up, build it up electron by electron to tell us things we hadn't learned before. He could have solved puzzles that had bothered philosophers and scientists for millennia. And instead, there isn't a single quantum equation or a single quantum property in the entire book. It's all metaphysics. He even said, physics is the house of knowledge, and metaphysics is the scaffolding, without which further construction would be impossible. Now, if you're a philosopher, you might want to imagine we need this much metaphysics. If you're a physicist, maybe this much. But the point is, we really do need metaphysics to give us a better understanding of the universe, and that's something we'll do unscientifically. Now, consider the philosopher, Soren Kierkegaard. And he grew up at a fascinating time. It was right after the Enlightenment peaked, and people who once thought they had this special place in the universe were now seeing, through applying the scientific method to everything, that they lost that special explanation for what they had. Instead, they went into secularism, they went into nihilism, they believed life was meaningless, and Kierkegaard saw all this, and he worried that people had forgotten how to exist. And so he proposed a solution. Now, to understand the solution, we can think of it as like we have objectivity and we have subjectivity. These are two opposites. And in objectivity, we have what's scientific, what's unbiased, it's impersonal. And then with subjectivity, it's unscientific, it's personal, it's everything that relates to us as subjects. And so Kierkegaard said that in pursuit of a truly objective truth, we have to eliminate everything subjective from it. We have to make ourselves impersonal to it. But if we do something like that, if we have, say, a theory of everything that's completely objective, by necessity, we've eliminated everything that meant something to us about it. So we'd be indifferent to it. So what good, then, is a theory of everything if it means nothing to us? Ultimately, to find science that moves us, we need to have these subjective, unscientific elements to them. They'll make us care. Kierkegaard understood this, and he actually called his book the concluding unscientific postscript, perhaps to acknowledge the value in doing things unscientifically. Now, earlier I mentioned that the Dalai Lama believes that science, not Buddhism, gives us what's right and wrong. Which begs the question, why then does he follow Buddhism if science is what tells him these things? And I'd wager that it's because he's not interested in finding an objective truth from Buddhism. Rather, he's interested in something subjective, something meaningful to him on a personal level. It's the same as when Shakespeare invented almost 600 words to create his plays and poems. He wasn't interested in following the proper English method. He had something meaningful to say, and it didn't fit within the proper syntax. Likewise, when we deviate from the scientific method to go about the moon landing or the Riemann hypothesis, we're not doing it because we're interested in right and wrong. We're doing it because we want to do something meaningful, like landing on the moon, or maybe finding a theory of everything. And that we will do unscientifically.